Voyager 1, the most distant human-made object in the universe, has once again begun sending usable information back to Earth, following a period during which it transmitted only unintelligible code. This breakthrough, accomplished by NASA engineers, has reignited interest and excitement within the scientific community and among space enthusiasts. The buzz reached new heights when renowned science communicator Bill Nye claimed that Voyager 1 had detected 300 massive objects in space, sparking widespread speculation and raising profound questions about their nature and origin. For nearly 50 years, the Voyager missions have provided humanity with some of the most remarkable insights into the solar system and beyond. Originally designed for a 5-year mission, these spacecraft have far surpassed expectations thanks to a revolutionary idea conceived by Michael Minovich in the 1970s. This idea, known as the gravitational assist or slingshot maneuver, allowed the Voyagers to harness the gravitational pull of planets to propel themselves deeper into space. Launched just weeks apart during the summer of 1977, Voyager 1 and Voyager 2 initially set out to explore Jupiter and Saturn, which they did with unprecedented success. Voyager 2 continued its journey, becoming the first spacecraft to conduct close-up observations of Uranus in 1986 and Neptune in 1989, marking a historic grand tour of the outer planets. Instead of ending their missions there, both spacecraft set out on a far more ambitious journey, venturing into deep space. In 2013, NASA confirmed that Voyager 1 had officially entered interstellar space, a region beyond the Sun's influence, defined by the end of its particles and magnetic fields. It was likened to stepping out of a bustling city into an infinite, star-filled wilderness. 5 years later, in 2018, Voyager 2 followed, reaching an incredible 17.7 billion kilometers from the Sun. These two Voyagers remain the only human-made objects to have entered interstellar space, acting as cosmic messengers and continuing to transmit invaluable data that help scientists better understand how the solar wind, charged particles from the Sun, interacts with the interstellar medium. Their discoveries have illuminated the structure and behavior of the heliosphere, the vast bubble formed by the solar wind that shields our solar system from cosmic radiation. One of the key findings from the Voyager's crossing into interstellar space was that cosmic rays are 3 times more intense beyond the heliopause, the boundary where the Sun's influence ends, than within it. This contrast between the relative calmness inside the heliosphere and the chaotic activity outside was unexpected and pivotal in enhancing our understanding of space weather and radiation. NASA scientists have even combined data from other missions with Voyager observations to piece together a more comprehensive view of the Sun's interaction with the interstellar medium. Among the most fascinating discoveries was a persistent low-frequency hum detected by Voyager 1, which turned out to be the faint vibrations of ionized plasma drifting through the vastness beyond the heliosphere. This suggests that interstellar space is not a silent void, but a dynamic, vibrating realm. Nicola Fox, head of NASA's Heliophysics Division, emphasized the lasting significance of the Voyager missions, stating that their contributions over the past 46 years have transformed our understanding of the Sun and its far-reaching effects. Despite their advanced age, both Voyagers continue to operate using radioisotope thermoelectric generators powered by plutonium. As this plutonium decays, it produces less heat, forcing engineers to make difficult decisions about which systems to keep running. In a surprising move, they even turned off heaters essential for keeping instruments warm. Yet, since 2019, all 5 scientific instruments aboard the spacecraft have continued to function in temperatures that would typically freeze any other technology. This resilience has baffled scientists and stands as a testament to the robustness of their engineering. The commitment and ingenuity of the Voyager team have been instrumental in extending these missions far beyond their intended lifespan, enabling humanity to explore the cosmos in ways never before imagined. The sun, though it appears to be a serene, glowing orb in the sky, is a dynamic nuclear furnace barreling through the Milky Way at around 450,000 miles per hour. It is enveloped by a complex network of magnetic fields that constantly interact with the remnants of long-dead stars found in the interstellar medium. Rather than blending seamlessly, the solar wind, a stream of charged particles from the sun, collides with this material, carving out the heliosphere, a protective bubble that stretches roughly 11 billion miles from the sun. Thanks to the Voyagers, scientists now understand this bubble not merely as a boundary, but as Earth's first defense against hazardous galactic radiation. Without it, life on Earth would face much more intense and damaging cosmic rays. As the sun continues its journey through the galaxy, the size and shape of the heliosphere may change depending on the interstellar environment it encounters. Studying these changes is crucial for predicting space weather and ensuring the safety of future missions into deep space. Communicating with the Voyagers, which are now over 15 billion miles from Earth, is an enormous challenge. Any command sent takes around 22.5 hours to reach the spacecraft and another 22.5 hours for a response, making each interaction nearly a two-day affair. Compounding the difficulty is the spacecraft's outdated hardware, which requires communication in machine language, a basic programming method that predates modern operating systems. NASA engineers must carefully craft instructions using assembly language and pseudocode, which helps automate tasks without using too much memory. These software updates are not just routine fixes, but vital adaptations that keep the spacecraft functional despite their age and distance. They represent a delicate balancing act between maximizing performance and conserving power in machines never designed to last this long. Voyager 1's recent detection of 300 massive objects in interstellar space has added a new layer of mystery to their legacy. While NASA has not yet confirmed the nature of these objects, the implications are tantalizing. Could they be rogue planets, massive clumps of cosmic debris, or perhaps something entirely unknown? This unexpected finding challenges our current understanding of what lies beyond the heliosphere and invites scientists to rethink the structure and contents of interstellar space. It adds to a growing body of evidence suggesting that interstellar space is far from a static void. It is a dynamic, evolving environment shaped by magnetic fields, stellar winds, and remnants of supernova. When Voyager 1 crossed into this region, it encountered much higher than expected pressure and density, suggesting that the interstellar medium is more turbulent and complex than previously believed. Another significant revelation from the Voyagers is the insight they provided into cosmic radiation. Inside the heliosphere, the sun's magnetic field offers some protection. But once the spacecraft exited, they were bombarded by high-energy particles at intensities never before measured directly. This information is crucial for the planning of future manned missions to Mars and beyond, where astronauts will need advanced shielding to survive extended exposure to this radiation. Data from Voyager is helping engineers and scientists design better spacecraft and develop strategies for protecting both crew and instruments during long-duration space travel. Beyond the science, the Voyager missions carry deep philosophical and cultural significance. Each spacecraft contains a golden record, a time capsule of Earth's diversity and humanity's aspirations, curated by Carl Sagan and his team. It includes greetings in 55 languages, traditional music from around the world, natural sounds, and images portraying life on Earth. If ever encountered by an intelligent extraterrestrial civilization, this record offers a glimpse of who we were. When the Voyagers launched, It's a poignant reminder that these spacecraft are not merely tools of science, but emissaries of a species yearning to understand its place in the universe. Despite the increasing difficulty of keeping them operational, NASA remains committed to maintaining contact with the Voyagers for as long as possible. Each day, they continue their journey. They carry with them the hopes, questions, and legacy of humanity, boldly traveling where no one has gone before. Each signal received from Voyager 1 or Voyager 2 is treated as a precious gift, one more heartbeat from a mission long expected to fade away. The fact that they continue to function and transmit data defies not only the expectations of their original designers, but also the very limits of technological endurance. Operating on technology from the 1970s, these spacecraft are now navigating realms no human-made object has ever reached, their instruments still gathering and relaying data from the fringes of the solar system and deep into the interstellar void. Their power is dwindling, and systems have gradually been turned off. Yet every byte of information they send back carries untold value, adding new pieces to the cosmic puzzle that has fascinated humanity for centuries. What makes the Voyager missions so profoundly significant isn't just their longevity or distance traveled, but the frontier they represent. These spacecraft are not merely drifting into darkness, they are pushing the boundaries of what is known and challenging long-standing scientific assumptions.